Today, on how it's made. Boomerangs, designed for a good rate of return. Barbecues, all the juicy details about how they make them. Pinball machines, we go to the factory to check out the game plan. And strobe lights, all flash and plenty of substance. You could say that the boomerang is a bit of a throwback to primitive times. Back then, people threw sticks to hunt, and that's likely how they discovered that certain bent sticks would circle back. Boomerangs have come a long way since then and are now finely crafted gizmos. Boomerangs come in many shapes, but each one is all wing, like those of an aircraft. They start with a solid piece of wood. Here, the growth rings are highlighted to demonstrate that the later growth is narrower. This means it's denser, so it will be easier to work with. The woodworker takes 16 strips of that dense wood and places them in a steam box for 20 minutes. The steam makes the strips much more flexible. They're so elastic, they can be bent by hand. Watch how he arcs all 16 layers at once, with very little effort. Now he has the basic form of a boomerang. To improve the contour, he clamps the strips in a boomerang-shaped mold. They remain clamped for a day or two, long enough to dry and harden into the bent form. He spreads glue onto each bent strip, then clamps them together in the mold again. This time, the mold has been coated with wax to prevent the glued strips from sticking to it. He leaves it to set overnight, then removes the laminated boomerang shape. It's solid, but far too chunky to fly. He slices it into pieces 8 to 12 millimeters thick. The piece of laminated wood yields about 6 thinner pieces. Each one is light enough to be a boomerang. But it needs more form, and he has to get rid of those rough edges. So he outlines a more refined design and cuts it out. But there's an easier way to make a boomerang, with sturdy aircraft plywood. With plywood, there's no need to laminate and then physically bend the wood. He simply cuts out the pattern, then sculpts the tops of the wings with a drum sander. He's made the tops of the 2 wings curve upwards, but in opposite directions. It's this contouring that will make the boomerang fly in a circle. On some models, embedded lead weights help to balance it. That laminated boomerang gets the same contouring, but he uses files instead of a drum sander. Laminated wood responds better to this technique, but it's much more labor-intensive and it takes skill. One mistake in the shape and size, and it will throw off the aerodynamics of the boomerang. But our woodworker has the job down to a fine art. To tune the boomerang, he softens it over a steaming kettle while twisting the wings into an upward flip, similar to an airplane wing. This blower dries the wood to ensure it stays flipped. He then sets the boomerang on a flat surface to check the curve. He sprays sealant onto the boomerang, and finally, he gives it several coats of lacquer for a high-gloss finish. And now these boomerangs are ready to fly circles around the competition. The origin of the barbecue is clouded in a bit of a smoky haze, but it's believed that native Caribbeans were the first barbecuers. Of course, back then, they didn't have charcoal grills. They roasted their meat over a smoky pit. Today, people still love a good cookout, but now we have better equipment. To make a basic charcoal grill, they start with big steel discs. A machine with rollers coats each one with soapy lubricant. Then they feed it to a press that stretches the disc into a big bowl. Stretching steel is a bit tricky. It could tear if they don't lubricate it well enough, so they make sure each disc gets a generous application before it goes under the press. The press swiftly transforms the flat piece of steel into a round bowl. This is a back view of the press. Using mechanical might, the ram delivers 500 tons of pressure. They use a similar type of press to make the lids for the barbecues. An operator inspects each part for splits and cracks. Then it's over to a press that trims the rim. They toss the scrap into a bin for recycling. Next, they spin the barbecue bowl while an automated roller flanges the rim. After that, they pierce the bowl to make holes for ventilation. Now they bring out all the guns, as in welding guns. The guns fuse metal couplings to the bowls to serve as attachments for the barbecue's legs. Here, they load handles into a fixture. A turntable swings into action and delivers the bowl to welders that fasten the handles to each side. At another station, they're working on the barbecue lids. They weld a handle onto each one of them. This one will allow the chef to lower the lid to control the cooking temperature, and then lift it again when it's time to flip the burgers. The barbecue parts now travel on an overhead rail to the wash station. Here, nozzles hose them down with soapy water and then rinse them. Once they're dry, they head over to the finishing department. Here, they dust them with a glass powder. Then it's into a furnace that's red hot, 848 degrees Celsius. The furnace bakes the glass dust into an enamel finish that will protect the parts from rust and stains so they'll last for years. Next, they go under lights that are as harsh as daylight. This exposes any defects in what should be a mirror-like finish. The technician examines each part inside out. A punch machine now makes dampers from aluminum. It simultaneously cuts the shapes and embosses the company's trademark onto them. A damper is a handy attachment that enables the chef to control the flow of air to the grill. They put nylon grips on the handles. And they install the damper over the lid's ventilation holes. It's up to the consumer to do the final assembly, something that should take just a few minutes. And then it's time to pull supper together. Before video games, the pinball machine reigns supreme. It's lost ground, but it's still a winning concept. You pull a plunger to get the ball rolling, but the action is real and not on a screen. You hit flippers and navigate bumpers to the clamor of clanging bells and flashing lights. No wonder it's not yet game over for pinball. The game of pinball is unprogrammed and unpredictable. To make a pinball machine, they string reams of wire for the electronics. There's more than 3/4 of a kilometer of it in one pinball machine. They use different types of color-coded wire, winding it around pins and attaching it to connectors on the circuit board. There's a detailed set of instructions and an engineering drawing to keep things from getting in a tangle. They remove the wires in loosely tied bunches. This allows them to move freely as they dip the tips into a hot metal soup to solder them together. Not all wires are soldered. Others get attachments called lugs. They crimp them onto the ends of the wires with a hydraulic machine. These lugs will be used to connect wires to attachments on the playfield. They hook up the cable to a testing board and check every circuit. They place the playfield, adorned with colorful art, onto the bed of nails with foam strips. The nail bed rises and presses against a header. The nails prick the back of the board, but the foam strips stop them from going through. These nail holes will serve as markers for installing pinball targets and tactical features on the playfield. Next, they drill a few holes, then cover the playfield with a metal template to drill more holes. These will be used to mount some of that pinball gadgetry onto the playfield. They hammer in anchors to attach the metal railings that keep the silver balls from rolling off the playfield. There's a lamppost, followed by some plastic bumpers. They install 115 flashing lights. Now it's time to permanently attach all that wiring. They solder some directly onto the board and fuse others to switches. They bolt a speaker into the cabinet for some major sound effects. This spring-powered plunger goes in next. Without it, you couldn't take your opening shot. They attach a toy villain and add a ramp in the shape of a sword, along with a few other toy characters. It's time for the inaugural run. They roll the pinball into every target and mechanism to test the switches. There can be 70 switches in a game. They press all the buttons as a computerized system diagnoses any malfunctions. They don't miss a shot as they put the pinball and the gadgetry through their paces. If everything works, they slide the playfield into the cabinet. It gets a shatterproof window because it could take some abuse from enthusiastic gamers. They lock it down with a metal bar. Finally, they mount the header, and this pinball machine is wired and ready for action. Mention strobe lights, and perhaps the 70s disco comes to mind. But you find strobe lamps, the proper term, by the way, on aircraft wings, in those red and blue lights on police cars, and on towers and tall buildings to warn low-flying aircraft. They even play a role in photography and on factory production lines. A strobe lamp emits repeated flashes of high-intensity light. At this factory, production begins with glass blowers. Using a ribbon burner, they heat glass tubes to 1600 degrees Celsius. This softens the glass for bending into a specific shape. At the same time, they blow air through a rubber hose attached to one end of the tube. A cork in the other end traps the air inside. This builds counterpressure to prevent the tube walls from collapsing inward as the glass softens. The size and shape of the glass tube varies by model, but its job is always the same: to house electrodes, lead wires, and xenon gas. The electrodes conduct the current, which charges the gas with electricity, making it illuminate. This factory makes several strobe lamp models, some in large quantities for the mass market, others in small quantities, custom designed for specific clients. With mass-produced models, after glass blowing, automated machines take over. Custom orders are handmade from start to finish. Workers make even the electrodes manually. They weigh a precise amount of metal powder and pour it into the cavity of a press that's similar to what pharmaceutical factories use to make pills. This powder is a blend of several different materials, but the company won't divulge what they are. The press applies 4 tons of pressure, compressing the powder into a pellet. The factory inspects every pellet to ensure it meets quality standards. The pellets then undergo a process called sintering. They bake for 9 minutes in a hydrogen-fueled oven, hydrogen being one of the hottest types of fuel. The 1700 degrees Celsius heat fuses the powder particles into a solid unit that won't crumble apart. Next, they weld a lead wire to each electrode. Insert 2 electrodes, one for the positive current, one for the negative, into each glass tube, then melt that end of the tube closed. Then they attach a wire called a trigger lead. It works like a car's ignition, prompting a transformer to send a high-voltage electric pulse to the electrodes, illuminating the gas. This automated machine assembles the factory's mass-produced models. Before starting it up, workers load the components: a pair of electrodes made by an automated pill press, and the glass tube on top. Now the machine takes over. It vacuums out the air in the tube, then injects xenon gas, then melts the glass tube closed under the electrodes, then cuts off the excess glass. The tube's interior must be completely free of contaminants for the gas to illuminate. So just before the vacuum fill and seal operation, a hot coil encircles each tube to burn away any impurities. On custom-made models, workers do all these steps manually. The strobe lamp is finished and ready for installation. This model is for those warning lights you see on tow trucks and road construction vehicles. It goes into a glass reflector lined with metallic film. A transformer regulates the voltage. Its 3 wires connect to the positive, negative, and trigger leads protruding from the lamp. A glass lens cover seals and protects the lamp within the reflector. Another use for a strobe lamp is in a stroboscope, an industrial device that factories use to perform quality control inspections on high-speed production lines. Once you calibrate the light pulses to the right interval, they visually stop the action so that cameras or workers can examine the goods. The size, shape, and configuration of a strobe lamp's components, along with voltage and other electrical specs, determine how long, how often, and how quickly the light flashes.